Durham, North Carolina. So it's been a lot of travel already this week.
All right, Bob, just so you know, we are officially recording, so don't say anything embarrassing.
So FYI, I'm in Windsor, Colorado. It's overcast and snowing right now. So, okay, Corey, you want to get started?
Yeah, I will. All right, so welcome to the second webinar in the ALTA 2024 webinar series. I know that not everyone on the call is familiar with ALTA, so I just want to take a second to share who ALTA is. ALTA is an association of laboratories across the country that's committed to ensuring quality data from agriculture communities and encouraging the development, use, and acceptance of proven agriculture testing methods. Our goal is to be an industry leader in ensuring consistency, precision, and accuracy across ag labs nationally. Just to get an idea of who we are, I like to share a membership list. So this is kind of our member labs, though we're open to membership outside of just laboratories. And with that, I'm going to hand it off to our speaker today, who most of us probably know, Bob Miller, to talk about soil carbon. So Bob, I'm going to stop sharing and I'm going to let you start sharing, hopefully.
Thank you very much, Corey. I'm moving on to share my screen. Okay. Come on. There we go. Thank you, everybody, taking some time on this Thursday afternoon. You know, the soil carbon thing has, and I say things, carbon sequestration, transaction payments for paying a sequester of carbon has really been on our focus here over the probably last 3 or 4 years. And to that end, I'm going to talk to you about the ALP Soil Carbon Laboratory Proficiency Program. So soil carbon sequestration is, you know, we hear it in media, we hear it at farmers meetings, we hear it from industry, we see it, you know, on our LinkedIn pages. This has been a very, topic that's really coming to focus here. And it's all based on trying to sequester carbon, and in the market we're talking about soil carbon with an agricultural with a credit transaction going out there for the amount of sequestered carbon. When we start talking about this, it's really about carbon transactions and how is the lab industry going to participate in this? I mean, we've already had samples go through laboratories. We've talked about the methodologies. I think the methods are pretty much in place. Probably some issues with the soil sampling scheme and how to get an accurate soil sample for quantitating this. But my focus of this whole presentation is really relying in on how's this going to impact the laboratory industry? So let's talk about the general terms here. So when we're going to quantify soil organic carbon, it's going to require 3 measurements. Obviously, a bulk density, so determine what the density of that soil sample that was collected, a measure of the soil organic carbon, and then conversion of that back to 100% dry matter basis. You know, we can look at a soil and we can put it in a drying oven at 40 degrees C and call it dry, but it still retains moisture. And using the 105 standard, where we get rid of all that initial water out of the sample, I mean, we realize there's water and hydrated shells at the mineral level, but at least getting into a standard static concentration. Now, I want to make a point. Soil organic carbon is not all the carbon in there. On alkaline soils, we have a fair measure of inorganic carbon. So when I look at this, and maybe I'm wrong on this, but I look at this, I say, well, the sampler is responsible for the sample, and the lab's responsible for the organic carbon measurement, the dry matter. So that bulk density falls on the shoulders of the soil sampler. And here at the right screen, you see just a diagram how we're going to calculate how many tons of organic carbon that's in that soil. So now, you know, ALP has collected 260 soils in the last 17 years and ran them through proficiency program. We run 15 soils a year. We have a pretty good database of what we have for carbon measurement, soil organic carbon. And I've just picked out 5 soils here. These range from a 4.4 down to 0.4% soil organic carbon. And I've listed that soil organic carbon uncertainty measurement. Now, this uncertainty measurement is based on the measurements, because we measure each sample 3 times in each particular laboratory for each soil. This is just based on 3 measurements within the laboratory in that calculated soil organic carbon uncertainty. This is pooled over 14 labs. So obviously there were labs higher than this and lower than this. But you can see here that as the concentration goes down, the relative uncertainty, the percent uncertainty of that median goes up. And this is a well-known phenomenon. This is called the Horowitz trumpet, because as we reach detection limit values, that standard deviation starts to expand, and therefore we end up. And you can see here at the very low end of carbon concentration, 0.43%, we're almost 12%, almost 13% variability there in that. Now, all the proficiency soils run by ALP. They're processed at 0.72 millimeters. That's a 28 mesh Tyler stream. Okay. The reason we do that is we want a nice homogeneous sample for the proficiency pits. Now, the question is, how does measurement uncertainty impact carbon sequestration? So here's 2 examples. I have a soil organic carbon of 2%, and the plus or minus uncertainty is 0.1. And I throw in a bulk density based on, just some numbers I've pulled out of literature from like what Larry Sahicek has done at North Dakota State. I put it at 0.06. So if we calculate the quantity of carbon based on a 30 centimeter sample, you can see there we end up with a relative uncertainty of about 10% of that value. Again, this is based on an RSD within the laboratory for organic carbon of 5%. Conversely, if I go to sample number 2 there, and I have a same 30 centimeter column, the same concentration of organic carbon, but using the much reduced RSD, ends up with a plus or minus 0.02% soil organic carbon. Now I have a relative uncertainty of the quantity of carbon in that 30 centimeter sample of 5%. I reduced it by half. Now, granted, I've taken RSDs from 5 to 1, but because it's a calculation, remember, it's concentration times bulk density, I end up with a 5% relative uncertainty. Now, how does that impact us? What's the reality of this in carbon transactions? Well, let's take another example. So the carbon marketing, at least as much as I know about it, which is probably a fraction of a thimbleful, but we're talking about taking a sample at time 0 and a sample at some time in the future, and we're going to pay a grower for the amount of carbon he's sequestered. So using this just example here, I have a time 0 of 2% organic carbon, a bulk density of 1.4, and a 30 centimeter depth. And now I'm going to look at this same test 5 years later, and I've increased the soil organic carbon by 0.2%. Now, you probably might say, well, is that really realistic? Well, I kind of think we're probably talking about these kinds of numbers. Maybe it might be 0.3%. We hear people pushing this whole concept at 1%. Well, I don't think that's quite realistic. Now, using these 2 calculations, time 0 and time 5 years, I end up with a relative uncertainty I'm going to throw out there. It's 5%, and that bulk density of 0.1. So at the time 0 concentration in that 30 centimeter depth, I'm in 84 tons per acre, plus or minus 7.6. At 5 years, using these levels of uncertainty, I end up with 92.4 and 7.5 tons per acre. And we say, well, wow, we've increased carbon in these samples 8 tons the acre. Yeah, that's a net change of 8.4. But when we calculate in the 2 uncertainties, remember, we got an addition here. The uncertainties compound themselves, and we end up with 8.4 plus or minus 10 tons the acre. So if we can't even pay anybody because our measurement uncertainty is such a point that we have insufficient information here to make any kind of payment on a 0.2% increase after a time of 5 years. Okay, so how good do we have to get for doing carbon analysis for this kind of activity, right? So Larry Sahicek and Jacobson back in 2007, they were using a scalar prismatics carbon analyzer. This is a very small sample size machine instrumentation. I think it's on the order of 200 or 500 milligram sample sizes. They did a milling study. And what they found in that milling study using 3 North Dakota soils, as we go from 2 millimeter minus down to 0.15 millimeter minus, we can radically reduce the amount of the standard deviation and in essence the RSD of that sample. Now, we did a pilot study because we started, and I say we, ALP, we started getting involved in this, and we did a study with LECO last fall. It was a 928 unit. We took a sample and we milled it to 0.18 millimeters. And this was a soil out of our ALP archive, and it had an organic carbon content at 3%, just 3.07%, standard deviation 0.13. We were able to attain a 95% confidence interval of 0.02% on that sample, because as we mill the sample down, we end up with a very nice homogeneous material. If you do the RSD on this sample, we're talking about RSDs of 0.4%. Unfortunately, that's probably where we're going to have to go as an industry for doing testing for carbon analysis. Now, many of you might say, wow, Bob, that's probably pretty not realistic in this kind of world. Well, I think this is one of these things as a lab industry, we're going to have to prove ourselves for. Now, kind of give you a little quick background. You know, our entire soil testing industry for fertility is based on a grower service management, giving out, you know, information to a grower, to a consultant, to make nutrient management recommendations. The focus is a payment for service for managing crop fertility. And we've been able to live in this easy world. And I say that because, you know, if you're off 10, 15% on your number that you provide the grower, the recommendations, there are enough, I'll say, gray area in it. It can easily handle that. It's not a precise process, okay? And we have the issue of sample collection, which is a whole separate entity that I'm going to push to the side. But the basis of soil carbon testing as advanced is to quantify a mass of soil carbon for the purposes of auditing a sequestration of carbon content for a payment transaction. In essence, the laboratory is entering into the contractual process, right? We're going to say, this is the number now, this is the number in the future. We're directly tied, as I say, we, the lab industry, is directly tied to that transaction. And as a result, we have to have very accurate, precise soil carbon measurements. So, soil carbon credit transactions are going to necessitate a redefined sample processing as the samples come into the laboratory. It's going to require detailed laboratory quality control. And we're going to have to really polish our skill sets to get instrumentation and techniques on that instrumentation that reduce the measurement uncertainty. Now, several of you probably are not going to like this because now we're talking about an EPA type setup where we have required sample prep and analysis SOPs that follow those that have been used in the environmental world for the EPA. I understand it, but now we're dealing with a contract for payment and that we're going to be certifying that there was a change in carbon or the quantity of carbon that was sequestered. So this has already been underway in other parts of the world. Philip Mulvey has been working on this for probably the last 7 or 8 years in Australia. They have a patent valid on a method for quantitating soil carbon. I was recently in Australia in November. I visited a lab that's doing this type of testing. They're running 1,200 samples a week. This is a very rigorous process, and I'm going to save that whole subject about the process itself for another webinar. And in fact, I'm planning to invite in Graham Lancaster, who runs a laboratory in Lismore, Australia, to talk about that. So this process is outlined by Philip Mulvey. Is basically, this is an outline of what they do for their carbon samples in Australia. It's a very rigorous process. And just an example of how the samples are coming into the laboratory. Yes, they air dry the samples. That's kind of the standard thing. but they go to great lengths to remove out coarse mineral fragments like gravel. They go to great lengths to bring out fragmented root materials and record how much that they removed. The sample then goes through a splitter, and then they mill it to 0.25 millimeter. And it goes through homogenization there with the soil blending, and then it's prepared for analysis. And literally, prior to milling the sample, they're going to split the sample into that sample for carbon analysis, inorganic carbon analysis, and that part of the sample that goes on for routine type things. So the last thing I'll say on this, I was astounded how much this procedure is outlined by Mulvey requires for rigorous QC, method detection limit statements, blanks, certified reference standards, etc. And all results are put on this 100% dry mat basis. Now, because the laboratory is now providing data that's for a dollar transaction here, I think it's going to be imperative that we're going to have to archive soils, because if we do a field for a grower at time 0 and we come back 10 years later, we're probably going to need to run those two samples side by side. That way we can quantitate and say, hey, yes, he increased carbon, or he did not. And obviously, when money's tied to things, this becomes a big matter. Now, so I think we're seeing, when this thing really goes forward, credit transactions for carbon is going to necessitate a chain of custody. So we know where that sample came from, who collected it, what time it was, et cetera, et cetera. It's going to call a revision of the soil sampling protocols. It's going to call a redefinition of these laboratory skills. I kind of already echoed that. On the carbon analysis in the laboratory, I think we're going to have soil organic carbon uncertainties of less than 3%. I mentioned 5 earlier. To really pin this down, we're probably going to be that, because I think there's going to be a lot of cases that if we have a very marginal increase in carbon content, we have to document that it really is either non-significant or it is significant. We're also talking about total organic carbon detection limits on those soils that have calcium carbonates or magnesium carbonates. And we're talking about method detection limits and carbon on the instrumentation side of 0.02. So, and lastly, and this is where ALP fits in, verification is going to be needed of laboratory analysis performance. That means proficiency testing. That means audits, and probably, and we don't like hearing this, but some kind of certification standard that says this laboratory meets standards for doing this type of testing. So to that, ALP is launching a soil carbon analysis program next month to provide proficiency testing services for soil analysis carbon sequestration. Now, you say, well, our lab's already in ALP. Why can't we use the regular LP samples? After looking at the methodology, after looking at what standards we're going to have to come to, we realize that we're going to have to put a lot more effort into preparing these types of samples. And because of this, it has to be a separate program activity. We cannot ship out our standard samples for carbon because we want to prove that laboratories can meet this high standard. The focus is only on 5 soil test parameters related to carbon sequestration: dry matter content, i.e. how much moisture is in the sample, total carbon, organic carbon, and inorganic carbon. This is going to be a triennial program. Bob likes a three sample a year program, but only 4 soils each cycle and 3 measurement replicates for each one of these 5 tests. This is a very condensed program. Soil carbon is separate from the standard ALP soils, as I've just said, because it requires this special preparation to provide quality packaging and maintain that sample integrity. So why ALPs? Why are we doing this? Well, first of all, I have 24 years experience preparing proficiency samples. Also, ALP has a large archive of soils collected across 57 states and Canadian provinces. You have a huge archive of materials. Technical experience, been running an accredited proficiency testing program with CTS now since 2006. They have that expertise doing statistical analysis for laboratory PT data, and they do good quality, effective reports for the quality control management side of things. The last thing is, I have a personal relationship with a lot of laboratories. I like to work with laboratories to resolve problems. I also love the feedback we get from laboratories about telling Bob, hey, you got to fix this in the program. In fact, I just had a comment from being at the MOSPOG meetings in North Carolina about our data portal needs to have some upgrades to it, but that's a talk for another time. And then lastly, you know, we're tied to government agencies and industry participants, instrument manufacturers, but all of our focus has been on providing to improve lab testing. This picture at the upper right is a picture from that laboratory in Lismore, Australia. When they're running their 1,200 samples a week, they have these special hoods that they have in place for removing gravel, roots, etc. This is how much time. The director of the laboratory told me they were spending close to $40 Australian to clean up samples in the prep room. Now, why ALP? Well, first of all, we have this big soil archive. We have soil organic carbon values in our archive that range from 0.25% to almost 28%. So we have this archive that we can pull soil material up. Secondly, to ensure this homogeneity and integrity, we're going to be milling these samples from what we have right now in the archive down to 0.18 millimeter. The reason for that is that's kind of seems to where the, you know, Horowitz trumpet really starts to flatten out. We don't get much, we get very marginal improvement in homogeneity as we go below 0.1. Double sieved. All samples are going to be double sieved and homogenized so we can ensure that they're a very uniform sample. Furthermore, when we started talking about this, we realized the moisture content is going to be a critical component to measures a PT parameter. So all soils are going to be preconditioned at 20% relative humidity for 48 hours prior to packaging and distributed in vapor barrier enclosures for proficiency distribution. I mean, this is something I don't think very many PT programs other than the NFTA has had to go to, but we're going to have to do this if we want to really pin down our carbon analysis. The program's based on 4 proficiency soils, each submitted as blind pairs. We're going to do a paired analysis, and I'll explain why we're doing that to each one of the participating laboratories. Those analytes, as I said earlier, are limited to 5, and I have these listed here on the left: dry matter combustion, soil pH, soil carbon, soil organic carbon, soil inorganic carbon. And as you'll notice, each one of those headings, we have some options. And so when we were putting this program together, the first thing we thought of, because some of these methodologies have different ways of handling them for that particular parameter. For example, soil organic carbon, we could do a high temperature oxygen combustion, and we may use an oxygen pretreatment to get rid of inorganic carbon. Or we may have an instrument that has a staged combustion cycle. We're going to be collecting metadata for each one of these 5 methods to kind of discern out, is that method versus the method A versus method B for dry matter, are those similar or are they different? And the real purpose behind it is to provide an education to people about, you know, this method has some issues and variability here, you know, and the whole point, as I just said, is to collect this data so that we can further discern statistically about how these methods may compare. Now, that metadata collected is going to be very limited because we don't want to burden people collecting a lot of additional information. What we're going to ask for is a parameter method reference that the laboratory is using. Pretty simple stuff there. It's a one-time collection of that information. Secondly, we want to know what the sample size is, because we know sample size really is integral in what the variability is on the measurement. We want to record the instrument vendor and the model. And then lastly, the method detection limit. Each cycle will ask for this information. It's going to be generic one time through each time, but we're going to have pull down menus on the spreadsheet to kind of fill in those values. So we plan to, at the end of the second round, and I'll tell you why at the second round, to start providing this information back to lab participants. We can say, hey, this particular instrument responds or has a tighter RSD than another, or this particular sample size is inherently giving us more variable data, because we think that's valuable information to our laboratory participants. Now, real briefly, hey, there's 3 major instruments out there in the market. I'm sure the LECO combustion analyzers is in many of these labs, but I also know scalar prismatics and elementor cubes are out there. All these instruments are pretty well defined for doing carbon analysis. They're all high temperature oxygen furnaces. Some have different types of CO2 detectors on there. And as a result of these different manufacturers, we have varying sample sizes here. But the bottom line is we realize this, but we want to collect this information so that we can use it for statistical evaluation. So the soil carbon proficiency programs, we're going to provide you that standard statistical report on each one of the soil test parameters, the number of results, confidence limits, interlab precision, et cetera, that you've seen in the ALP program. That you're going to recognize. But next, we're going to do supplemental statistical analysis called Yoden pair analysis, as developed by AOAC. What this allows us to do is we can say if we run sample A and sample B, and they're very similar, but they're not the exact same concentration, we can parse apart that maybe there's a particular bias in there on these samples. And I'm not going to get into this detail at this point, but I want to kind of give you an idea that we're going to be doing something above and beyond the standard statistics that's well recognized out there in other testing industries. Now, for 2024, this soil carbon program is provisional. In other words, we're not going to certify anybody. We're just providing you data back. In September, we plan to do a participant assessment review of the program. And I'll just say this first round that we're going to do here in 2 months, or a month and a half, actually, we're going to have, this is like a shakedown cruise, right? We're going to have to figure out what works, what doesn't, what can be effectively modified to give us a high quality program and address any issues that labs come up with. Our whole point is that we're trying to provide a quality program, but inherently something always comes up that we need to address. Now, how much? We put this price of this program at $650 per year. It's 3 cycles, April, July, November, 4 soils per cycle, 5 test parameters. Pretty simple, each in triplicate. We will provide with each PT round an instruction about how these samples are to be analyzed, because this isn't going to be part of the standard protocol that you're probably very familiar with. Because we're putting these out in airtight jars, we anticipate when you open the jar, you're going to run your unknown sample or your 4 unknown samples, and then probably recalibrate and run the 4 unknown samples the second time and the 3rd time. That way, because once these jars are opened, these samples are now going to be really re-equilibrating to the humidity in the lab, and the moisture content's going to change. And so this is going to be a very tight process. If you have interest in this program, we want you to email me at this address. I will forward these on to Collaborative Testing Services, who's right now working on building up the website for this and building up the data portal for this particular testing. Now, I have some additional notes, as Colombo does, just one more thing. A protocol on soil carbon sampling is needed. USDA is working on establishing SOPs for the sampling. I think this program is going to be, our goal is to say, we're working on the program to make all the labs better. An official document of soil sample preparation. I anticipate we're going to have to put one of those together. We can use Bill Mulvey's plan as an outline, but I think we're going to have to do that because we got to standardize this process. Yeah, the ALTA program, Agricultural Laboratory Testing Association, is going to develop a soil carbon testing certification program based on the ALP proficiency data. Specific requirements of what you as a laboratory industry want to see in that PT program for certification, plus or minus score, whatever. We need your input for that. It's really critical to build this program around what the participants have an expectation. We plan to have a webinar with Graham Lancaster later this year, probably midsummer, to have him come in and talk about what he's been doing with soil carbon testing in Australia, about the mechanics of how his lab runs them, the pitfalls he has. I'll tell you, after being down there and spending a day with him, it was a real challenge for him to hire how many people it takes to process 1,200 samples a week. So with that, it's time for questions. So please jump in. I'm open for this, and I like to hear feedback. This is something new for us, but I think because we're talking about credit transactions for carbon, we're going to have to set a whole different standard than what we're used to for this industry. So, questions? Go ahead, Corey.
Sorry, I was having a hard time finding that unmute button. Yeah, so I think we have some great questions in the chat, and they kind of got scrambled the order, but we'll start with, when you were talking about ball milling, the question was raised, how much does ball milling at 0.15 millimeters cost? There was the estimate from Larry that at $1.25 per sample is their estimate for the cost. Larry, I'd welcome you to come off and expand on that estimate and that thought if you're willing to, and then maybe do that before Bob responds and his thoughts. Bob or Larry, I saw you went off mute, so feel free.
I got to find my unmute button too. I've got two ways of unmuting. Anyhow, yeah, it depends on the soils, and Corey and I were kind of going back and forth a little bit here. I figured about $1.25 running 16 an hour, based just on my experience. Running about 16 samples an hour. I've got a ball mill that can run 4 samples at a time, and if we time it right, sequence things right, we can run probably 16 an hour with a good operator. Again, a lot of it depends on your soil. If you got sandy soils, it takes a lot longer to reduce the sample. And the problem with the sandy soils is that whoever's operating the milling operation, they get kind of tired of having to remill those sand grains over and over again, which the tendency is to just kind of toss them. You got a few left on the sieve, and toss them. And I usually make them actually put them into the sample when they get tired, because that way we don't lose any sample. Because otherwise you're biasing your sample.
Yes,
and that's a huge problem.
Larry, quick question: how big a sample did you put in your ball mill?
10 grams.
10 grams.
If I can do more than that, but 10 grams is about the optimum as far as enough sample that we can get a good uniform sample.
Okay.
Out of the larger sample. And then it also depends on the time. Now, what I've also done is I've sort of worked out by experience. Usually we have to mill them twice or run them through the mill twice. Is the first time I set it at about 10 minutes, and we adjust this depending on the texture. A clay sample you can probably reduce in 5 minutes, but sand soil will take a lot longer. So there may be times we have to rerun or remill the sand residue up to maybe twice after the initial milling. Clays, usually if you mill them too long, they get stuck in the jar, and you spend your time scraping the clay out of the jar because it packs to the side.
Larry, for the sake of time, Ben Waddle has a question. What model of ball mill are you using?
We've got our own construction.
Okay, I'll leave it at that.
It's just a roller, just a couple of rollers, motorized rollers, and I can't even tell you what the speed is. I use a 500 mil jar.
Okay,
with six pieces of grinding media in there.
So for the sake of time, we want to get to the other questions. I'll just make this input. I have a name of a manufacturer that they used in Australia. It's a ring mill, and I believe that they are running probably close to a 50-gram sample, and they were telling me that it was a 5-minute run per sample, and they had 5 ring mills. So let's move on to other questions.
Yeah, thank you, Larry. That's great. And I think that I just want to highlight that from a lab perspective, this is a big concern, because a lot of labs doing this work are not anticipating having to ball mill grind, not grinding to 0.15 millimeter. And that is a big change in their workflow that has to be considered and anticipated when the lab is considering taking on some of this carbon testing work. So another question from Rebecca. More important to reducing MU is that we need to have good defendable understanding of our MU and report that out to our clients on total carbon results. I don't know, Bob, do you want to comment on that, or Rebecca, before Bob comments, do you want to expand on that thought any more detail?
Yeah, Rebecca, if you could do just a short, brief thing about this, and please introduce yourself.
Sure. Yeah, my name's Rebecca. I'm CEO at Woods End Laboratories in Maine. A little bit of context is we've been running soil organic carbon in service of the carbon market for about 3 years now. And just in the past 2 years, we've done maybe 50 to 60,000 soil organic carbon measurements to supply that market and to serve that market. And I think that the case study that you present, Robert, is really influential, and it tells a really great story, and it really illustrates the importance of measurement uncertainty. But I see more and more, soil result reports, they don't have a plus or minus, they don't have error bars. So I think one way that we can kind of recuse ourselves from any legal ramifications of reporting the quote wrong number is to be upfront about what our measurement uncertainty is. So add those error bars to our results, and that'll help protect us in the long run. But then also related to that is using a defendable method to define our measurement uncertainty. And there's lots of different ways to do it. As long as we're open and transparent about how we're calculating our measurement uncertainty and what that measurement uncertainty is, it'll protect us in the long run from people coming back and saying, you've got the quote wrong number.
Yeah, I totally agree with you, Rebecca. And as I said earlier, this is a provisional program, and we're trying to, what my goal is here is to show everybody, I'm not talking about the sample prep, please. We're not talking about pulling the sample in the field or the sample prep on the lab. I want to prove that this is the level of uncertainty we have right now, and then working to refine that. So
sure. Yeah, and I think if you're measuring strict soil carbon, that'll be really important. My experience with the market and these clients is that they're looking for soil carbon stock measurements,
yes,
where bulk density is part of that calculation. And in my experience, I find that the errors associated with the bulk density measurement far outweigh the errors associated with the analytical equipment to measure carbon. And that's the biggest source of error in my experience.
Okay, so I want to have other opportunities for other people to jump in here. Any other questions? Corey, could you go queue, or is there anybody else have other questions? Because this is a good time to answer these things rather than getting an email, on next Monday morning.
So since we have Rebecca queued up, she actually had another question for you there. Rebecca, do you want to read that out loud and ask that question to Bob too?
Sure. So you started going through the accepted methods for inorganic carbon testing as part of your program. And I was just wondering if you would open it up to volumetric calcimetry.
I'm willing to open it up. I don't want to go too far, 55 different methods, but sidebar, we have pressure calcimetry there. Volumetric's not that much different from that.
Right.
So to me, you measure pressure, you measure volume. It's all, the gas equation, PV and T. So I'm good with that.
Bob, would you anticipate, or Rebecca, you may actually be able to answer this. Would you anticipate more or less the same result with pressure versus volumetric?
I would, yes.
As long as it's calibrated correctly. But
you calibrate with calcium carbonate anyway, and if the operator has good QC control and a standard reference, etc., I think they're equivalent methods. And remember too, this is only going to apply to soils that have calcium carbonates in, and I kind of pull a rule of thumb, and it's not completely perfect, but rule of thumb is until the pH exceeds 6.5, we don't have to worry about these carbonates.
Yeah.
Unless the field was limed recently.
And I think that this gets into, a lot of times people don't want total carbon, they want total organic carbon, and this direct TIC measurement to account for the inorganic carbon piece is, I think, a real piece of our question. And it kind of leads to another question down there. I see acid pretreatment for organic carbon. Can Bob explain a little bit more about that? So yeah, Bob, I'd love to hear you talk about acid pretreatments and make a recommendation.
Yeah, so there's, I gotta say, I'm old school, that I want to do a total carbon on a sample and I want to do an inorganic on the sample, and the difference is organic carbon, okay? But there are a number of labs which are running total carbon, and then they will run a acid pre-treated, or maybe they don't even run total carbon, they just run an acid pre-treated sample through their instruments. Now, some labs have tried using HCl. I got to tell you, HCl is a death nail to most of these combustion instruments, because the chloride gets into the system and it causes great corrosive issues. I do know labs that are using phosphoric acid. There are some labs using some other types of inorganic acids out there. And you know what? I'm not opposed. That's why I just put that in there. That's one of the things we're going to collect metadata on. So if they're doing an acid pre-treatment of the sample, we're going to have them identify the acid. I'm not going to get into the details of how much acid, et cetera, but we want to know those so we can piece those out of the number of labs who are giving us results. The last thing I'll say on this is, and this relates, two of these instrument manufacturers, both Scalar and Elementar, both now have staged combustion systems. And what I mean by that is they change the temperature in the furnace. And so they pull off the inorganic carbon early, then they come back and they pull off the total carbon in the sample. And so you get it, the instrument gives you a direct profile about the carbon concentrations from the different places. There is a ISO official method for this that comes out of Germany. I think it's a DIN 1493, I think is what it is. It's there. Now, I will say this. Almost any lab that I'm aware of that's running that stage profile for inorganic carbon and total carbon and organic carbon, I believe those analysis times are now in the 8 to 10 minutes area. So now your productivity, you're talking 7, 8 samples an hour.
Yeah.
You know? It's great if you want to buy a lot of instruments. So enough on that.
Bob,
more
hold on. I will
questions.
comment. So first, I want to flag one thing. LECO also has a staged combustion instrument.
Okay.
But the big things that I like to flag when I talk to labs about this is cost goes up and per sample analysis time, as you highlighted, goes way down, and it makes them so dramatically inefficient. The other thing I want to highlight, Rebecca's comment, acid pretreatments damage these instruments. The instrument manufacturers have some struggles with this. Alta's actually working with LECO to work through some guidance with their instruments about what is an acceptable acid concentration level on samples, because this is a huge issue that's not really fully understood, because a lot of times these combustion analyzers are designed for multiple purposes besides soil testing. And you know, this acid pretreatment wasn't necessarily what was included in the original design and thought process, and now they're trying to work through it. So I think that Rebecca's comment there about some of these acid pretreatments can really damage instruments is something that's really important.
Absolutely.
So hold
Additional
on,
questions?
scrolling down. Yeah, okay. So Heather Davis mentioned that LECO has their sample, but it takes a long time. Yes, 100%. They all do. Rebecca, we did a study running different combustion temperatures, all beyond 1000 C on our LECO instrument, and found very different results for TC. Combustion temperature may be a metadata point to look for. Bob, do you want to comment on that?
Much appreciated.
Is ALP considering bulk density?
Okay, now, you know, I'll just say I've thought about this, and I don't know. You know, it's one of those things. Now we're getting into the realm of samplers, right? And I don't know, very few of our labs that are on this Zoom call or this webinar, they don't pull their own samples. So it's subcontracted to somewhere else, okay? But this is something that has to be considered. Now, to me, the more critical thing at this point is a protocol how to pull that sample, right? And I got to say this, I pull a lot of cores myself, and we have to come up to the point, if you're pulling that core, how do you know, you know, I've used a 6-inch, a 2-inch ID sampler with a 6-inch depth on it. When I drive that in the ground, when do I stop? You know, when it hits that compaction point, these kinds of things need to be addressed. Yes, I will say we'll consider it. If there's interest in it, we can pursue it.
I would just point out that from a certification standpoint, at Alta, that bulk density component is a real challenge.
Yeah.
That's just a real challenge to figure out how to standardize that. And that also kind of leads itself. I know bulk density is being measured in the lab and calculated by the lab, but as Bob alluded to, what we're really talking about is a field standardization issue. And when you look at some of these carbon program protocols, they all have different rules around how many samples are taken per field, what the depth is, how to handle a situation where you're supposed to pull 1 foot, but you can only get 6 inches. All these things are added variation and challenges that a lot of times labs are asked to deal with, but we really have no control over. And I think that that's an important thing to just at least be aware of.
More questions?
Larry said we use Scalar, and it has 2 channels. One for IC, uses phosphoric acid, and an IR detector. I'm assuming that Larry is saying he likes his Scalar with that comment. Rebecca would like for us to come up with a good, quick bulk density field measurement. I agree, Rebecca. As soon as I get that copyrighted, I will let you know. And then Larry pointed out again, the bulk density is an operator issue for sure.
Absolutely. Absolutely. Well, I mean, if we really get down this road and we're paying people what I say is a good fee for pulling the samples, then we'll have techniques, maybe even, a sensor on there that says, okay, you've driven that probe far enough, right? And we can get good numbers. So again, the thing I want to stress about this is I don't think too many in our industry has really reside on the fact that when the samples dropped off at the loading dock or on, at the point it enters the lab, that's where our responsibility starts. And I really think we haven't thought about how much prep's going to have to go into cleaning up this sample. Fine roots, stones, whatever, that's going to need to be addressed. So. Okay, I know we've been online here for 50 minutes. If you have any more questions, we can do them now, or we can kind of wrap this up with Corey.
Yeah, so I mean, first off, if anyone has any more questions, let's put them in the chat. I did just want to share, and I'm struggling with the technology. You guys can see here, Alta is hosting 2 more webinars in March. There are QR codes right there where you can click and register for those events. They're a part of the first FRST partnership that Alta has, and are focused more on interpretation of soil fertility versus soil carbon. But we would welcome anyone on this call definitely participating and being part of those conversations. With that, Bob, if you have anything else that you want to add, I'm open to it right now for sure, or I'm happy to end the call a little bit early if no one else has any questions.
So just the last couple things, we anticipate our ALP samples for our standard proficiency round cycle 53 will go out the 18th of March. We plan to have these soil carbon program, have labs start the enrollment process as soon as they want to. If you enroll in the program, you're going to be have access to other things that you will not see in any other program. And what I mean by that is, if you participate in the soil carbon program, we're going to have a couple of special webinars, the one with the people in Australia talking about what their activities are, and something with Alta talking about what kind of statistics and what kind of certification process that we're going to talk about. It's going to be exclusively only for the labs that's enrolled in the program, because that's who's paying the fee. The last thing I'll say is, Chris Sirica, my boss, is online right now out here. I know he's got a lot of things going on with our accreditation, because we're in a process of completing our accreditation for 2024. But please forward me your interest in this program, and we will move that on. Just FYI, there's a note here from Rock River Laboratories. They mentioned that they'd like to see Alta do a certification program for samplers. My comment back to that is, we got to have an SOP for that. We have to have an SOP before we can go out and certify samplers. So happy to have you guys work with us on that, and maybe pull together a group of people who have expertise in this area to help build the SOP before we have the certification standard. So Other than that, I will turn it back to Corey and we're done.
Yeah, no, I think we're good. That's great. Rock River, I love your support in asking these great questions. And if you have a solution for how we can do a soil sampler certification, Scott, I suspect that's you sending these messages. Feel free to put that together for our next Alta meeting in August.
So
But-
for Scott, we'll need to do a 30-second TikTok, okay?
But okay, with that, I'm going to end the call, guys. Thank you very much.
Thank you all for attending. Bye.